The question over here is find the probability that a hand of 5 cards in a poker contains 4 cards of one kind. So a hand of cards is defined as a set of 5 cards. So I've got 1, 2, 3, 4, and 5 cards over here. So this is basically a hand of cards. Now, in poker, oh well, not in poker, but in a deck of cards here, what I have is I've got these suits over here. So I've got suit 1, suit 2, suit 3, and suit 4. So these are my clubs. These are my clubs here. These are my spades. These are hearts. And these are diamonds. And then this is over here. These are actually called kinds. So the columns over here are called kinds, and I've got a total of 1, 2, 3, a total of 13 different kinds here. Okay, so 13 kinds, and a total of 4 rows over here, which makes up my suits. Okay, these are my four different suits. Now find the probability that a hand of 5 cards in a poker contains 4 cards of one kind. So given this hand over here, let's just hard code certain values. So let's say if I were to select the ace of clubs here. So if I would take ace of clubs, ace of spades, and ace of hearts, and let's say ace of diamonds. Okay, so this could be one such hand where I've got 4 cards that all belong to the same kind, and the kind here is aces. So all of these belongs to the same kind. But keep in mind that for this last card over here, I've got a total of 48 different choices. Because if I were to select this card, this one, and this, what's remaining in this entire pool of 52 cards, I've got 48 cards that are still remaining that I could select from. Okay, so if I were to do this, now let's just think about the question here is what is the probability that a hand of 5 cards in a poker contains 4 cards of one kind. And this is, we could think of this in terms of counting, where I'm first going to count the different ways I can arrange my cards, my 5 cards. So different ways I can arrange 5 cards, basically 52 choose 5. But the other way to think about the same thing is I've got 1, 2, 3, 4, and 5. There are 52 different ways to select the first card. There are 51 different ways to select the next card. 50 different ways to select the third card, 49 different ways to select the fourth card, and 48 different ways to select the fifth card. But as I multiply these out, this is just going to give me the arrangement. And in the arrangements, I'm going to have some of the permutations some of the permutations or some of the arrangement of a certain combination that keeps on repeating. And we looked at this in lecture. So what I'm going to do now is I'm going to remove them. So when I remove them, I'm going to take this entire multiplication over here. I'm going to divide this by 5 factorial, which is nothing but 52 choose 5. Okay, so this gives you the exact combination over here. Okay, so given this 52 choose 5, now what I'm going to do is I'm going to start thinking about how many different ways can I count where I've got this hand of 5 cards that contain 4 cards of one kind. Okay, so in this case, well, I'm only telling you these are my aces here, and there are 48 different ways to select the last card. Okay, so let's apply the product rule here. Now, in the product rule, you could think of the selection of the last card as, let's call this as task 2, and the selection of the first 4 cards as task 1. How many different ways can I select task 2? Well, this is 48 over here, and let's call it N2. So there are 48 different ways to select the last card, and there are N1 different ways to select task 1. N1 in this case happens to be 13. This happens to be 13 because I could either put in their aces, I could either put in their 2s or 3s, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So there are 13 different ways. To actually select these 4 cards over here. Okay, so this is going to be 13 times 48 different ways 13 times 48 gives you the different combinations. It gives you different combinations that are going to contain 4 cards of one kind. Now, when I take this and I divide it by 52 choose 5, this is going to give me the probability. It's going to give you the probability of a hand of 5 cards in a poker that contains exactly 4 cards of one kind.